Sean again, an application engineer here at WinDaq Instruments. In this demonstration, we'll show you how to display and record RPM, or revolutions per minute, using WinDaq software. Here we see the output of a tachometer, an instrument used to measure rotational speed. But how do we convert this pulse output into a frequency and ultimately into RPM? To do so, we'll use the frequency acquisition method, which you can see here is grayed out. To enable the frequency acquisition method, we'll choose Preferences from the Edit pull-down menu, select Maximum Sample Rate, and uncheck the Auto option. This temporarily disables the anti-aliasing filter. You'll see now that the frequency acquisition method is available. Here we see a message indicating that the anti-aliasing filter is in fact disabled. You'll notice too that the frequency is currently 0 Hz. That's because we need to set a frequency window size and trigger level. To do so, we'll choose Preferences again from the Edit pull-down menu, click the Frequency option, and enter a window size. The window size is essentially just a sample of data used to calculate frequency. With the window size entered, we'll set a trigger level by clicking the Set Level button and placing the tick mark somewhere in the middle of the waveform. Click the Frequency and True RMS data acquisition link below for more information on choosing the appropriate window size and trigger level. Notice now that we're displaying frequency in Hertz. To convert Hertz to revolutions per minute, or cycles per minute in this case, we'll click the Cycles per Minute checkbox in the Channel Settings window and click OK. Now instead of displaying cycles per minute, we want to display RPM. So we'll choose Engineering Unit Settings from the Edit pull-down menu and change the EU tag to RPM for revolutions per minute. Now you can see that we're actually displaying RPM, and you see the number increase and decrease as revolutions per minute increases and decreases. In our example, RPM is never going to exceed 20,000 revolutions per minute. So we'll choose Limits from the Scaling pull-down menu and change our top limit to 20,000. Now you can see the trace rise and fall along with RPM. When you have multiple RPM signals to acquire, the frequency acquisition method on an analog input is a good option.